Dear students, today I am presenting here the self-learning topic on resistors connected in series and parallel. What is the meaning of series connection and for parallel connection? Uh, how the voltage and currents are distributed, that we'll see. See, the resistors are assumed to be connected in series when the ends of one resistor is connected to the starting terminal of the other, so that same current flows through both the resistances. Let us say current is I is flowing through the two resistors. Even though the current is same, because of different resistors, voltage developed across these resistors will be different. V1, V2. So we can write here voltage V1 is I into R1, voltage V2 is I into R2 by Ohm's law. So now we have here V1 is I into R1 and V2 is I into R2. And applying KVL to the loop here, the total voltage V is V1 plus V2. So we have this equation V is equal to V1 plus V2. V1 plus V2. So next, this substituting the values of V1 and V2 into this, we get V is equal to I into R1 plus R2, and this R1 plus R2 can be combined into a single resistance, let us say R equivalent, and hence we get V is equal to I into R equivalent. This R equivalent represents the equivalent resistance of series connected resistors. There are two resistors connected in series, and hence equivalent resistance is equal to sum of individual resistors connected in series. So from this, I can now find current. I is equal to what? V divided by R equivalent. So if I know what is the total voltage, if I know individual resistors R1 and R2, I can calculate R equivalent and then I can calculate what is current. So that is the use of this relation. Next, resistors in parallel. The two resistors are connected in parallel when the start terminals of both the resistors are connected together and end terminals are connected together. Let us say these two are start, they are connected together. End terminals are also connected together. And if we assume that there is a voltage applied to this parallel combination, we can analyze how these parallel connected resistors behave. So if the applied voltage is V and current coming is I, and these resistors are R1 and R2, so what happens? This I is coming here. There is a junction. This wire is also a single node. That's all. Okay, it's all single node. So I coming here will divide here because these are passive elements. They absorb the current. Let us say this is I1 and this current is I2. So I is dividing into I1 and I2. So we have by KCL I is equal to I1 plus I2. Now what is this I1? See, voltage V is applied between this line and between this line, and this line is acting as a node, this line is acting as a node. So therefore voltage across this resistor R1 is same V, voltage across R2 is also V. So what I can write, V is equal to I1 into R1. Similarly, V is equal to I2 into R2. Now you take here, what is I1? I1 is equal to V by R1 plus I2 is V by R2. So I can take V common. I get here 1 by R1 plus 1 by R2. So you see here V into 1 by R1 plus 1 by R2 will give the total current. Now we know that by Ohm's law, voltage V is I into R, and therefore I will should be equal to what? Voltage divided by resistance. This is general formula for the resistor. So now what is happening here? I can write this as I is equal to V divided by this value reciprocal. So that is R equal, V by R equivalent at represent. So what I'll get 1 by R equivalent. 1 divided by R equivalent is nothing but 1 by R1 plus 1 by R2. Or therefore, R equivalent is equal to R1 R2 divided by R1 plus R2. So if two resistors are connected in series, then we have R equivalent as R1 plus R2. If two resistors are connected in parallel, then R equivalent is equal to R1 into R2 divided by R1 plus R2. It's important. So next, we have some numerical problems are given. You please try to solve these things, and you can understand how to find out the equivalent resistance when resistors are connected in series parallel combination.